All right, so we'll do a quick review for the test, and I'll just go over some problems that are similar. So 3.7, that was on solving systems. All right, so you want to make sure that if you're given two systems, you know how to solve graphically. So let's say we had something like this. X squared plus 2 and y equals, let's say, 2x plus 3. How do I graph those? How do I solve those when I graph? What do I have to do? Yep.
Do you set them equal to one another?
Algebraically, you could, and you'd have a quadratic to solve. But what if I want you to just do it graphically? Yeah.
Would you put both of them on the same graph and then see if they intervene?
Yeah. Put both of them on the same graph and see where they cross. Okay, I might have to adjust this a little bit since I just made this up. I don't know if they actually cross. I think they will. Thank you, Mr. Roy. Actually, it's perfect.
2 points.
So yeah, the possibilities that could have happened with a parabola and a line, they could have missed each other. They could have just crossed once or twice. So in this case, we get 2 answers. And what do I want to calculate? Intersect. Does the guess matter?
No. Well, yeah, because there's 2 intersection points.
Right, so whichever point I put the guess closer to, that's the intersection point it'll give me. Okay, so when you write down your intersection points, make sure you write down both the x and the y. So if this is a system, I'm looking for both the x and the y values. All right, so you could write your answer this way. 2.41, 7.83. Or how else could you write your answer? Yeah.
Well, you could write it like in the parentheses, right? Like x, comma, y.
Yeah, you could write it as an ordered pair. So one thing I might ask is just how many solutions there are. Okay, so in that case, there's 2. Right? So that's the first thing.
Also more. Isn't there 2 x solutions and 2 y solutions?
Yeah. There's one more intersection point right here. I didn't find this one.
Okay.
But you'd have to also do that one. Yep. So you should know how to find how many solutions there are. You should also be careful for something like, let's do this. Okay, so I'm going to graph them again, except I just changed the line a little bit. Okay, how many solutions are there now?
There may be actually 2, it looks like.
No, because that's going up straight, and the parabola is going to get wider and wider and wider than everyone can touch.
Yeah, so the point is it's off the screen, so you might want to just set your Ymax a little higher to kind of see what's happening. But make sure if there is something off the screen that you check that out.
Oh, you were right.
So it does intersect way off the screen. All right, so a lot of people for that kind of problem might say 1 solution, but it's not, it's 2. Okay, so definitely check for behavior that's off the screen. All right, so we said how many solutions, we found a solution, and that's it. Any questions on how you'd find the second solution? All right. Next thing you probably want to know about is vertical asymptotes. All right, so let's say I gave you something like x squared plus 5x plus 6 divided by x squared minus, let's say, 4x plus 4. How would you find the vertical asymptotes there?
Would you use the 2 degrees, the highest degrees?
That's in behavior model. Okay, so if you want the EBM, that's when you divide the highest degree term in the top by the bottom. But not for vertical asymptotes. Yeah?
I know you have to solve for x somehow.
Okay, solve.
Find that x equals answer.
for which part do you have to focus on? Because vertical asymptotes, this whole fraction doesn't matter really. It's just part of it that we want to focus on.
Oh. Isn't the +6 and the +4?
No. No. Vertical asymptotes, where do those happen? Those are where...
Oh, in the divisor.
Okay, when it equals what?
0.
0. Yeah, we're looking for where the denominator equals 0. All right. So what's the easiest way to make that denominator a little easier to look at? Factor it. Okay, so factor it. So we get x and x.
-2, -2.
Yep, -2, -2. And now how would the numerator factor?
5 and 1.
No, 3 and 2.
Yeah, so x and x. And what about my signs?
Plus and plus.
Plus, plus,
Yep. 2, 3.
2 and 3. Yep. So am I going to have a hole in this graph?
Yes.
Okay, how come?
Oh, actually, no, because that would be -2 and positive.
Yeah, there's no common factors in the top and in the bottom. So we are going to get a vertical asymptote. And where will it be?
At 2.
At 2. And how do you write that as an equation of a line?
X equals 2.
X equals 2. Okay, not y equals 2.
Does it just focus on the numbers in the denominator?
That's what you start with, and then just make sure there's no common factors in the numerator. Yep. We can always graph this just to confirm it. So x squared plus 5x plus 6. Divide by x squared minus 4x plus 4. Okay, so as we approach 2, the graph should go either up very sharply and then come down very sharply. Yep. So that is a vertical asymptote. A lot of times we see the other part of the graph down in this section, but
There
that's...
must be a horizontal too.
Yeah, there is a horizontal asymptote here as well. Okay, we could find that. What's the horizontal asymptote? How do we find, what do you find that leads you to that?
You would use the x squared and the x squared.
And what's that called?
EBM.
The EBM. Right, so this wasn't part of the original question, but EBM, highest degree term in the top is x squared, in the bottom. And what does that reduce to? 1. So now, in the end behavior model, as you let x get really big, what does that number that I just circled approach? 1. And how do you write a horizontal asymptote? Y equals 1. And you can see that if you set your x min and max bigger, and it should look like it's getting closer and closer to 1 as you head left and right.
So is the end behavior model and the horizontal asymptote always the same?
No, because the end behavior model can have a variable in it. So if it has a variable in it, it could be like 1 over x. And then the horizontal asymptote is always just a number.
Okay.
So end behavior model can have a letter in it. If they don't, all cancel out.
So what if the end behavior model has an exponent or a letter in it? What happens with the horizontal asymptote?
So it depends where the letter would be. So if your end behavior model was this, then you ask yourself, what happens to that fraction as x gets bigger and bigger?
Gets smaller and smaller.
And what number would it approach?
0?
0. So the horizontal asymptote for this kind of problem is y equals 0. And that's the end behavior model. Okay, any other questions on that? All right, so vertical asymptotes. How about, let's do another one specifically with horizontal asymptotes, and let's use this actually. Find the horizontal asymptote. Okay, so remember, to find the horizontal asymptote, just let x get really, really big and tell me what y would approach. Yep.
8.
Yeah, y equals 8. That's your horizontal asymptote. Okay, what about vertical asymptote? I didn't ask for it, but I could. What's the vertical asymptote?
What's the exponent?
No.
Well, it's 1.
Nope, not 1. What's your end behavior model for that?
0.
0.
Yeah, so if you, first of all, to find an end behavior model for this, you need to put it all together as one fraction. So you would get a common denominator of x, and your other numerator would become 8x. Any question on how I got the common denominator? Yeah, I just multiply top and bottom by x. So now, what's the highest degree term in the top? 8x. And the highest degree term in the bottom? X. So these cancel out.
Becomes 8.
8, and that's where the horizontal asymptote comes from. Okay, that's why the end behavior model leads us to the fact that the horizontal asymptote is at 8. All right, now the vertical asymptote. What's the vertical asymptote? 0, yes. It's what would make the denominator 0. Okay, in this case, 0. So any questions on the horizontal or vertical asymptotes?
What would the horizontal be on this one? Did you?
Y equals 8.
Oh.
And the vertical is
Yeah, correct.
x equals 0.
And why does it equal 0?
Can somebody tell me why is it 0? Yeah.
It's whatever makes the denominator equal 0.
Right. It's whatever makes the
0
denominator
times
0. Yep. All right. Let's see. How about, you know what, let's go back to one that we had earlier and let's find the domain of it. So let's take this one, since we already did some of the work, and let's find the domain. Okay. What's the domain in this one? Yeah, it's going to be all real numbers except 2. It's always all real numbers except the zeros of the denominator, which we already found to do the vertical asymptotes. Right, so you can write it 2 ways. All reals except 2. Or how do we write it as an interval?
So negative 2, and then that u thingy.
What kind of symbol after the 2?
Parentheses.
Parenthesis.
U thingy.
Parentheses 2, infinity.
So you can write it
U thingy.
either way. Just if it's a multiple choice question, you're going to have to understand both notations.
So how did you get the 2 that's stuck on that for the domain?
Right. Somebody explain how we got 2 not being in the domain? Yeah.
Because it was what the vertical asymptote was.
Right. 2 is a value that is undefined in the function. Okay, vertical asymptotes are always where the function is undefined. So if you know those, you know what's not in the domain. Yep. How about,
The range.
Yeah.
wouldn't worry as much about range. I know we did a couple with homework problems that had range. You'd ask for both.
But it's not this.
Yeah, I would focus more on the domain.
Okay.
All right, let's try sketching a graph by hand.
Oh my god, I hate doing that. Simple.
Actually, you got stamp for
Okay, so how about, let's try x squared minus 3x plus 2 divided by x minus 4. Okay, what's going to be helpful to know before I try to sketch this?
Asymptote.
Asymptotes, yep. Let's start with the vertical. Where is my vertical asymptote?
4.
Yep, it's at 4. That's assuming the numerator doesn't factor into a common factor of x minus 4, but I know it's not going to because if I was going to factor the top, I'd be using a 1 and a 2, not a 4. So there won't be a common factor. Okay, well, what other kind of asymptote am I going to get?
You get a slanted one.
Right, we're going to get a slant asymptote. So in order to find that, we need to find the end behavior asymptote. So for that, we got to do long division or synthetic. In this case, you can do synthetic. So 4, and what would go on the outside?
1, -3, 2.
Yep. So bring down my 1. 4 times 1 gives me
4.
and then plus -3,
1.
and 4 times 1 again,
4. 6.
and 6. So what is my slant asymptote?
Is it 4x plus 1? Oh, why do I have a 1 in there?
X squared
Yeah.
plus 1. No,
No,
X.
it's x plus 1.
X plus 1.
Right, y equals x plus 1.
I have 4.
Okay, so I'm going to graph the slant asymptote, and then I'm going to graph the vertical asymptote, and that's going to give me a pretty good idea of my boundaries. And then I'll use the graphing calculator to check some points on each side of the vertical asymptote. All right, is there going to be a horizontal asymptote?
No.
No, slant asymptote takes the place of that. Great. All right, so let's.
How would we do this by hand if, like you said, we're sketching this without a graphing calculator?
Just like we're doing right now.
Okay.
The only thing I'm going to use the graphing calculator for is the table, because it can do arithmetic faster than me typing in numbers for x.
Alright.
I mean, I could use this regular calculator and plug in numbers for x. It's just going to take longer for me to square it, subtract 3x, and all that.
Okay.
So the table is just faster.
No, just one.
All right, so vertical asymptote. Slant asymptote. What's my y-intercept?
1,
And my slope?
X, and 1 over 1.
1, yeah. Okay, so put our line going through those points. So about, yeah, that's pretty good. All right, and where was my vertical asymptote?
Vertical's at 4.
Yep, that's at 4. Okay, so now what I'm going to do is I'm going to type in into my graphing calculator our problem, and we're going to try to check out what happens on each side of the asymptote. So let me bring this back up. All right, so we got x squared minus 3x plus 2. And we're going to divide by x minus 4. All right, so now what I'll do, go to my table. What's a value just to the left of the asymptote?
3.99.
Yep. So we're way down at negative infinity. Okay, so just to the left of the asymptote, way down here. How about a value just after the asymptote?
4.01.
0.1, and we're way up at positive infinity. It'd probably be good to check a couple values in this upper section. So what would be a good x value to see what's happening in that top section? Yeah, I would check 5, 6, maybe 7. Okay, just check those and see what it looks like. So 5, we're at 12, and 6, we're at 10. All right, so 5, I'm still off the graph. 6, I'm at 10. Let's do 7. See what. So 7, we're at 10. All right, so what's happening is it's probably somewhere between those two values. It's kind of, okay, So this would go up forever, and then it's going to kind of probably come down, curve, and then start getting closer and closer to that green dotted line. Right, so it'll just get closer and closer. All right, now the other section. Let's try 1, 2, and 3 just to kind of see where we're at. All right, so 1, 0, 2, 0. 1, 0, 2, 0. 3, negative 2. All right, so what's happening in this case is coming up, by going through those points, and then coming back down, and getting closer and closer to the asymptote. And that's how you'd sketch it by hand. Okay, we could always double check by looking at our graph. Okay, and that top part, you can see my window on the graphing calculator is that grid. So I'm just barely seeing the top part. Okay, if you want to see a little bit better, just set your Y max a little higher, and you'll see it. Okay, any questions on that one?
Are you going to give us graphing paper, like, for the test?
Yeah, there'll be a grid already on the test.
Okay.
Yep. All right, so you want to know how to graph?
The EBA and the Slant Asymptote are the same thing.
Yes. And I was going to ask a question about how do you find the EBA, but we actually just did it for this problem. Okay, so any question on how we got the EBA here? That's the slant asymptote?
Yeah, so it just, if it was like a rough enough like denominator, you probably would use long division instead, right?
Yeah, if it's anything more complicated than x plus or minus a number.
I'm
Yep.
terrible at the long division. Is that on the test?
It could be. I mean, you might have an easy one where you can use synthetic,
Yeah.
but I mean, it's not going to be like the worst kind of long division we've ever done, because we've done some that are a lot of steps, but it wouldn't be as bad.
Oh,
No,
Okay.
long is way easier. I don't know why. Like, it clicks with me better.
You like long division, but yeah, different people like it,
Like, you'd
different
think,
methods.
Like, synthetic would be way easier, but not for me. I don't know why.
So everyone's okay with the EBA for that one? All right. All right, so next kind of function, this one's kind of hard to make up. I'm going to ask you about local mins and maxes. Okay, so you remember how sometimes we have functions that have hidden behavior? I might ask you to find a local minimum or maximum in a function like that. So you just basically have to zoom in,
I was going to say.
Yeah.
right? For me to make one up like that, I really can't. I'd have to find one special.
It's just like if it asks you for a local min and max, that's basically saying just hone in and look,
Yeah.
zoom in basically.
Now, what if, let's look at this one closer. Let me zoom in near the x-axis. Because what I'm wondering is if this graph crosses the x-axis. Yes, it does. So let me zoom in a little more so you can see it. But just barely, I think it's going to cross the x-axis. Okay, so what I might do is give you this graph. You might start out with your standard window, and I might say the solutions or the roots of this graph are all in which interval. So maybe I'll give you choices. Okay, I'll say are the roots to this graph between, let's say, just make up some numbers, -2 and -1. Okay, are they in that interval? Are they between 3 and 5? Or are they between, let's say, 0 and 3? Okay, these are all intervals. Okay. Which interval there contains the solutions to the roots for that equation?
C.
Yeah, they're all somewhere, I'm not saying exactly what they are, but they're somewhere between 0 and 3. And you could trace. You could kind of figure it out too. So I can see that I'm negative around 2, and then all of a sudden I go positive. So there's a root pretty close to 2. It could be, actually it's exactly 2, and it's exactly 1. So 1 and 2 are the two roots, and they're both in the interval from 0 to 3. Okay, so any questions on a problem like that? All right, so you have something similar to that. Let's go back and look at number 4 again. Let me ask another question. Okay, what, as x approaches 4 from the positive side, what does f of x approach? So as x approaches 4 from the positive side, what is f of x approaching?
Negative infinity.
Careful, not as it approaches 4 from the positive side.
Oh, from the positive.
So it's like you're traveling
So then
this way.
infinity.
Yeah. Okay, you're heading towards 4 here. So as you start to head towards 4, your y values head towards what?
Infinity.
They head towards infinity. That's the answer. Okay, now, what about as x approaches 4 from the negative side? What does f of x approach in that case? Yeah, so now you're traveling this way. You're heading towards you're heading towards 4 from the negative side. And f of x is approaching negative infinity. Okay, any questions on that? Okay, so I'm going to ask you something pretty similar to that. We're going to do a word problem. So we've done different kinds, like the rectangle problems. You should know how to do those, like with perimeter. The concentration problems, where you add X ounces of pure acid to something. Okay, that's an important one to do. Does anybody have one of those two types?
Yeah, the boxes, or the rectangles, I mean.
The rectangle one?
Yeah, can you?
All right.
Unless I'm pretty lost.
So you could have something like, let's say you have a rectangle with an area of, let's say, I don't know, 200. And we'll just say 200 square inches. Okay, let x be the width. I want to find a formula for p of x, where p represents the perimeter of the rectangle, and we're going to write it as a function of the width. Okay, so find a formula for p of x. And then tell me the minimum perimeter. What's the smallest perimeter you could have and still make a rectangle? That's 200 square inches. So find minimum perimeter. Now, you got to be careful when they ask you this, because they could ask you, what is the width of the rectangle that creates the minimum perimeter? What's the length of the rectangle that creates the minimum perimeter? Or what is the minimum perimeter? You have to go through all the same steps to answer any of those questions. So, what do I know about my rectangle?
It's 200 square inches of
Yep.
area.
That's the area. Okay, what else?
X is the width.
X is the width. So what would the length have to be?
Something plus.
200 divided by x.
Yep, why did you say 200 divided by x?
Because you're going to have to do that. If you're doing it for area,
Right, area is length times width, so if your width is x, you've got to make the length something, so when you multiply them together, you get 200. Okay, now I can write my formula for the perimeter of that rectangle as a function of the width. Okay, what would be the perimeter of that rectangle?
2x plus 400 over 2x.
Well, 400 over 2x, that's just 200 over x.
Yeah.
That's the same thing.
You're just multiplying the top by 2 basically.
Or
Because it goes
400
2x
over x.
Right, 400 over x. Okay, so there's the formula for the rectangle with a minimum perimeter, or perimeter. Now I'm going to find the minimum. So let's graph it. So 2x plus 400 divided by x. All right, let's look at our table just to get some ideas of the perimeter. So obviously if you make the width small, very, very small, the perimeter gets very large. Okay? And then the perimeter is going to start coming down in size, okay, to a point, but then all of a sudden it's going to start going back up. Right? So it was going down, and somewhere between 15 and 25, it started heading back up. Right? So let's set our x max to 30 and see where it starts heading back up. So let's put that on 30. Let's put that on 0. And for my y max, what would be a good value?
Probably 60, 65.
Yeah, as long as it's above the minimum somewhere. Okay, so 65. And should we worry about negative perimeter?
Nope.
No. So I'm going to have a graph that comes down and has a minimum. Okay, so we're seeing it right in here. So second calc minimum. Pick a point left, right, and your guess. Okay, so the minimum occurs when x is 14.14. So that's, what was x again? The
Perimeter. I mean, width.
width. So what would the length be?
Wouldn't it be just 200 divided by 14.14?
Right, the formula for the length is 200 divided by the width.
It's going to be the same thing.
And that's also 14.14. So now I can answer the question, what is the minimum perimeter? How would I find it?
14.14 times 4.
Yeah, so the minimum perimeter you could have for a rectangular shape that would enclose an area of 200 square inches, the minimum perimeter, 56.58 inches. What did I say? 56.58. Okay, so on the test, I'm going to do one of the two types. I'm either going to do a concentration problem with an acid mixing in, find a certain concentration, how much acid would you have to add, or I'll do one with a rectangular perimeter problem. And let's see. All right, let's look at a transformation problem. So there's two kinds of problems left. I want to know the transformations you'd have to do to turn this into this. Okay, first of all, how many transformations are happening to turn, we'll call this equation 1 into equation 2?
3.
There's 3. Yep. What would be the first thing you would do?
Multiply by 8.
What is that 8 doing? So I'm looking for geometric names here, transformations.
I don't know the 8. Oh, the 8 is making it shift, not shift.
Yeah, it's not a shift.
It makes it bigger or small, like spreads it out or shrinks it down.
Okay, so what do we call that?
Stretch.
It's a stretch.
Yeah.
What kind of stretch?
A positive, bigger stretch.
Horizontal?
Well, that's one option. It's a horizontal stretch or
Vertical.
a vertical stretch. Okay, what if I wrote the original problem like this? What I just wrote is exactly the same question I just asked you.
Vertical stretch.
What is it?
It's a vertical stretch.
It's a vertical stretch. Okay, whenever you multiply by a number in front of the function, which is basically what this is doing, you just put it in the numerator, that's a vertical stretch. But that's not the first one we do. So it's a vertical stretch by a factor of how much?
8.
Yep. All right, and let's try to get the first transformation.
Shift left by 6.
No, the +6 is not a shift left and right.
It's up and down.
That's an
Up
up and
by
down.
6.
We'll handle that one after.
All right, so then it's the shift right by 3.
All right, we're going to shift right 3. That's the first one. So shift right 3, then vertical stretch by a factor of 8, and then what about the +6?
Then shift up 6.
Yep, shift up 6. Okay, so you'll have a question that asks you something like that. Okay, any questions on that one? All right, and the last kind of question is going to be something like we did today. It's going to be to solve something with some fractions in it. I'm just going to pick one that's in the homework because I don't know the answer to it, and we'll see what happens. 3x over x plus 2 plus 2 over x minus 1 equals 5 over x squared plus x minus 2. All right, so what's our goal here? What do we try to do?
Get the same denominator.
You want the same denominator.
Yeah.
Um,
Well-
Denominator.
well, so are we going to have fractions when we're done this?
No.
So no, we're trying to get rid of the denominator. I guess, so when you said common, I guess technically we're trying to get all denominators of 1. So we are trying to get a common denominator of 1 by wiping all of them out. So what would you have to multiply this first one by to get rid of its denominator?
Plus 2.
X plus 2, and if you do it here, you got to do it everywhere. And now what would you multiply the second fraction by? Yep. And if you do it here, you're going to do it here and here. And what would you multiply the third one by?
I think it's the same.
Right, because this denominator, if you factor it, it is the other two denominators. If it wasn't, that would complicate our problem a little bit.
On the test, is it gonna be that? Like,
Yes.
alright.
So what cancels out in the first fraction?
The x plus 2.
X plus 2. How about the second one?
X minus
X minus 1. X minus 1. And the third fraction?
X plus 2 and x minus 1.
Yep. Whole denominator. Okay, now everything that's left has to be distributed. So what do we get when we do out our first fraction?
3x squared minus 3.
X. Okay, second fraction?
2x.
And that's equal to
5.
5. All right, what should my next step be?
Combine like terms.
Yeah, I can combine like terms, and I can do something else at the same time.
Subtract 5 from both sides.
Yeah, and we'll get it equal to 0. So I get 3x squared
Minus 6.
minus x, yep.
minus 1.
And then minusing the 5 would give us minus 1. Okay, does that factor?
No.
No. Not going to be able to factor,
To quadratic formula.
so we'll do the quadratic formula. Okay, what's A,
3,
B,
-1,
and C?
-1.
All right. So when we plug in, what's my quadratic formula going to tell me?
Oh, yeah, -3. No, just 1 plus or minus the square root of 1, which is 1, minus 4 times 3 times -1.
Over 2 negative. Or is it, oh, is it 2, 3?
Over 6.
6, yep. Now you're subtracting a negative, so that's going to become positive. So I'm going to get 1 plus or minus square root of
12.
not 12,
13.
13.
13.
And unless you're going to find a decimal, that's pretty much all you can do. Those are the two answers. But what do we have to check?
If it's a extraneous.
Yes, we have to check if those are extraneous. Now, if you plug those in, would either one of those answers give you a 0 denominator?
No.
No. If I had gotten -2 as an answer, that would have been extraneous, or if I had gotten 1 as an answer. But I didn't get either one of those, so that's what we get. That was number 9 in the homework. So if I assign that one tonight, that one's,
You did, and
I
I
did.
did it wrong.
well, it's a good
You
thing.
already did the homework, David?
Yeah, I have corrected study period 8.
So lucky.
Let me check. So the book had 1 plus or minus root 13 over 6. Yep, that's what we got. So those are the two answers. Remember, when you do a problem like this, there's 3 cases. They could both work, both not work, or one works and one doesn't. Right, so that pretty much covers one of everything that's similar to what's on the test.